Hi there. Today we're going to be talking about physiology of the urinary system. Although you probably know that each person has two kidneys and you most likely can identify their general location, you may not be aware of the many functions the kidneys perform. On the other hand, you probably have a much better understanding of the function of the urinary bladder and a great appreciation for the attention required when it's filled with the urine produced by the kidneys. The urinary system consists of two kidneys, two ureters, the urinary bladder, and the urethra. A large volume of blood flows through the kidneys, which removes substances from the blood to form urine. The urine contains excess water and ions, metabolic waste such as urea, and toxic substances. The urine produced by the kidneys flows through the ureters to the urinary bladder, where it's stored until it's eliminated through the urethra. The kidneys can suffer extensive damage and still maintain the extremely important role in the maintenance of homeostasis. As long as about 1/3 of one kidney remains functional, survival is possible. However, if the functional ability of the kidneys fails completely, death will result unless the person receives medical treatment. The major function of the urinary system is to control the composition and volume of body fluids. The kidneys perform this function through multiple processes. First, excretion. The kidneys are the major excretory organ of the body. They remove waste products from the blood. Many waste products are toxic, but most are metabolic byproducts of cell and substances absorbed from the intestine. The skin, liver, lungs, and intestines eliminate some of these waste products, but they cannot compensate if the kidneys fail to function. Second, regulation of blood volume and pressure. The kidneys play a major role in controlling the extracellular fluid volume in the body. They can produce either a large volume of dilute urine or a small volume of concentrated urine. Thereby, the kidneys regulate blood volume and blood pressure. Next function, regulation of the concentration of solutes in the blood. The kidneys help regulate the concentration of the major molecules and ions such as glucose, sodium, potassium, calcium, etc. And next, regulation of extracellular fluid pH. The kidneys excrete variable amounts of H molecules to help regulate extracellular fluid pH. Next, regulation of red blood cell synthesis. The kidneys secrete a hormone, erythropoietin, which regulates the synthesis of red blood cells in bone marrow. Next is regulation of vitamin D synthesis. The kidneys play an important role in controlling blood levels of calcium by regulating the synthesis of vitamin D. The functional unit of the kidney is a nephron, and there are approximately 1.3 million of them in each kidney. Each nephron consists of a renal corpuscle, a proximal convoluted tubule, a loop of Henle, and a distal convoluted tubule. Fluid is forced into the renal corpuscle and then flows into the proximal convoluted tubule. From there, it flows into the loop of Henle. Each loop of Henle consists of a descending limb and an ascending limb. The limbs are further categorized into segments: the thin segment of the descending limb, the thin segment of the ascending limb and the thick segments of the ascending limb. The descending limb extends toward the renal sinus, where it makes a hairpin turn, and the ascending limb extends back toward the cortex. The fluid flows through the ascending limb of the loop of Henle to the distal convoluted tubuli. Several distal convoluted tubules empty into a collecting duct, which carries the fluid from the cortex through the medulla. Multiple collecting ducts empty into a single papillary duct, and the papillary ducts empty their contents into a calyx. The renal capsule and both convoluted tubules are in the renal cortex. The collecting duct and loop of Henle enter the medulla. Approximately 15 of the nephron, called juxtamedullary nephrons, have loops of Henle that extend deep into the medulla of the kidney. The other nephrons, approximately 85%, called cortical nephrons, have loops of Henle that do not extend deep into the medulla. The renal capsule of the nephron consists of the Bowman capsule and the glomerulus. The Bowman capsule consists of the enlarged end of the nephron, which is indented to form a double-walled chamber. The glomerulus is a tuft of capillaries that resembles a ball of yarn and lies within the indentation of the Bowman capsule. The cavity of the Bowman capsule opens into the proximal convoluted tubule, which carries fluid away from the capsule. The inner layer of the Bowman capsule consists of specialized cells called podocytes, which wrap around the glomerular capillaries. The outer layer of Bowman capsule consists of simple squamous epithelial cells. The glomerular capillaries have pores in their walls, and the podocytes have numerous cell processes with gaps between them. The endothelium of the glomerular capillaries, the podocytes, and the basement membrane together form a filtration membrane. And the first step of urine formation, fluid consisting of water and solutes smaller than proteins, passes from the blood in the glomerular capillaries through the filtration membrane into the Bowman capsule. The fluid that passes across the filtration membrane is called filtrate. The proximal convoluted tubules, the thick segments of the loops of Henle, the distal convoluted tubules, and the collecting ducts consist of simple cuboidal epithelium. The cuboidal epithelial cell have microvilli and many mitochondria. These portions of the nephron actively transport molecules and ions across the wall of the nephron. The thin segments of the descending and ascending limbs of the loops of Henle have very thin walls made up of simple squamous epithelium. Water and solutes pass through the walls of these portions of the nephron by diffusion. The thin segments of the descending limb of the loop of Henle is permeable to water and to a lesser degree solutes, and the thin segment of the ascending limb is permeable to solutes but not to water. Arteries and veins. A system of blood vessels allows the exchange of materials that occurs in the kidneys. The renal arteries branch off the abdominal aorta and enter the kidneys. The afferent arterioles arise from branches of the interlobular arteries and extend to the glomerular capillaries. Efferent arterioles extend from the glomerular capillaries to the peritubular capillaries, which surround the proximal convoluted and distal convoluted tubules and the loops of Henle. The veins of the kidney run parallel to arteries and have similar names. A structure called the Juxtaglomerular Apparatus is formed where the distal convoluted tubule comes in contact with the afferent arteriole next to the Bowman capsule. The juxtaglomerular apparatus consists of specialized cells of the walls of the afferent arteriole and the distal convoluted tubules. Certain cells of the juxtaglomerular apparatus secrete the enzyme renin and play an important role in blood pressure regulation. Urine production. The primary function of the kidney is regulation of body fluid composition. The kidney is the organ that sorts the substances from the blood for either removal in the urine or return to the blood. Substances that are waste products, toxins, and excess materials are permanently removed from the body, whereas other substances need to be conserved to maintain homeostasis. The structural components that perform this sorting are the nephrons, the functional units of the kidney. If you have ever decided to organize your junk drawer in your desk or kitchen, you may realize just how difficult it's to quickly sort through all its contents. In fact, you may have found yourself simply emptying the drawer onto a table and then sorting the contents one by one as you place objects into a safe group or a throwaway group. In a sense, the kidney uses the same approach when regulating blood composition. The throwaway items end up in the urine, and the safe items go back into the blood. Urine is mostly water and some organic waste products, as well as excess ions. Filtration. Filtration occurs when blood pressure non-selectively forces water and other small molecules out of glomerular capillaries and into the Bowman capsule, forming a fluid called filtrate. Tubular reabsorption is the movement of substances from the filtrate across the wall of the nephron back into the blood of the peritubular capillaries. Certain solid molecules and ions are reabsorbed by processes such as active transport and co-transport into the cell of the nephron wall and then from there into the interstitial fluid. Water reabsorption occurs by osmosis across the nephron wall. The molecules and ions that enter the interstitial fluid surrounding the nephron pass into the peritubular capillaries. In general, the useful substances that enter the filtrate are reabsorbed and metabolic waste products remain in the filtrate and are eliminated. For example, when proteins are metabolized, ammonia is a byproduct. Ammonia, which is toxic to humans, is covered into urea by the liver. Urea forms part of the filtrate, although some of it's reabsorbed, much of it's eliminated in the urine. Next process is tubular secretion. Is the active transport of solutes across the nephron walls into the filtrate. Consequently, urine consists of substances that are filtered across the filtration membrane and those that are secreted from the peritubular capillaries into the nephron, minus the substances that are reabsorbed. Alright guys, subscribe to my channel, put your comments on the comment section, Give me your likes. Bye bye. See you.